Hello, everyone. My name is Sean Holliday. I'm the Senior Director of Customer Success at Blaize. Super excited to be here and greatly appreciate the invitation from the MINDsLab team. Over the next 10 minutes or so, I'll provide a quick overview of Blaize, a little bit of information about our technology, talk about our relationship with MINDsLab, provide a demo, and then a quick wrap up at the end. Let's get started. At Blaize, we're all about providing a new type of computing, and specifically a new type of computing for AI and machine learning workloads. Our founders, Dinnaker, Kay, Satiki, and Val, all stepped away from long careers at Intel, where they worked in the GPU architecture division. Today, we have about $87 million in funding, over 300 employees worldwide, with our headquarters in El Dorado Hills, California. We also have several offices around the globe, a great list of investors, and are on our second generation GSP silicon. At Blaize, we have three key market assumptions that drive us. Number one is AI compute workloads are ubiquitous across the edge, enterprise, and cloud. Every business looking forward will be positively impacted by AI technology. Number two, AI compute workloads are 100% inferencing at the edge, and this is where Blaize's primary focus is today. As you move a little bit deeper into the network, about 80% of the compute will be inferencing, about 20% training in the enterprise and cloud. Number three, all compute and networking hardware manufacturers will require integrating scalable, native, or pluggable AI acceleration capabilities into their hardware. So at Blaize, we do three things really well. Number one is we've developed a new compute architecture called the Graph Stream Processor. This is focused on providing much more efficiency than traditional CPUs and GPUs that are being in utilization today. And I'll talk a little bit more about that later. Number two, the far left, we take this GPU architecture and we integrate it into a number of different hardware platforms. We have an embedded SOM in the lower right-hand corner of the picture that is meant to go into an embedded applications. Then we have two different accelerator solutions that go into traditional servers, industrial PCs, and such. In the center, what brings this all together is our software. At Blaize, about 70% of our employee resources are focused on software. We have two different versions of this. Number one is our Picasso SDK, which is a traditional coding environment for people who have experience in coding. And then we have AI Studio, which is a visual coding or code-free environment for business professionals that may not have a staff of data scientists and programmers. So at the heart of Blaize products is our GSP processor. Our GSP processor offers a total of 16 TOPS comprised of 16 cores, all of this at 7 watts average. If you look at some of our comparisons against GPU and CPU solutions, we utilize about 50 times less memory bandwidth. We offer about 10 times lower latency and 60 times better efficiency overall when looking at inferencing per watt per dollar. We do all of this while remaining 100% programmable. So you have the flexibility to program our device to run pretty much any network that you need to. So key tenets of our products, of our GSP architecture is faster execution time, lower memory bandwidth, lower latency, higher utilization as compared to CPUs and GPU cores, and overall lower power. So as I mentioned earlier, we have three different key products. I'll start off with the left-hand side first. These are our Blaize Pathfinder embedded modules. These are small modules about the size of a credit card that are meant to go into embedded applications, into a robot, into a camera, into a last mile delivery vehicle and such. These are full standalone, have ARM cores to run your applications, as well as our GSP architecture for your AI workloads. Second hardware product line that we have is our Blaize Explorer accelerator platforms. We have a traditional PCIe card, which is half height, half length, meant to plug into servers. We also have a very small form factor called an EDSFF form factor that's meant to plug into 1U server form factors to provide acceleration. As I mentioned earlier, at the heart of what Blaize does and where the vast majority of our resources are is in our software. We have two key software tools available for developers. Number one is our Picasso SDK. As I mentioned earlier, this is a tool meant for developers, for data scientists, people who are used to working and developing their own code. We offer the capability to work with TensorFlow, PyTorch, Caffe AI frameworks. We also offer the ability to program in C, C++, OpenVX. Our Picasso SDK has a very useful tool called Net Deploy. And a lot of times developers will receive a model from their data scientists. Maybe it's done in floating point 32, floating point 16, in order to have the highest accuracy possible. But it's not something that's easily deployable to a low cost, low power piece of hardware. So we have a tool called Net Deploy that automatically converts your network, say from a floating point 32 into an 8-bit int. It automatically does the quantization, the optimization, pruning, adding sparsity, whatever it may be, to compress the network while maintaining your overall latency and performance requirements. If you're a small business, a medical professional, financial professional, and you need to add in or take advantage of some of what AI can provide, we have a code-free environment called AI Studio. It's a very intuitive, GUI-driven or graphical user interface-driven software application that allows you to import a data set and then interact with our software, basically telling it what you would like to do. AI Studio will take that information, automatically build your network, and deploy it to our hardware without having to write a single line of code. So, we have two different development platforms: Picasso SDK for a traditional coding environment, and AI Studio for a visual code-free environment. So where do Blaize products go today? Well, if we look at where inferencing happens, I mentioned earlier, 100% inferencing is at the edge, and then as you move into the enterprise, it's about an 80-20 split between inferencing and training. So Blaize products today go into really one of four categories. Number one, at the edge. This is at the point of data acquisition, so integrated into the camera with imaging sensors connected, integrated in, on, or around the robot. But our Pathfinder products really go in applications where you need a small standalone compute platform, but you also have extreme latency requirements. Maybe functional safety requires you to have latencies at sub 100 milliseconds, for example. These are perfect applications for our Pathfinder SOMs. Take one step deeper in the network and go to number two, and this is where you enter the aggregation point. So maybe the networking switch or server where all of your camera streams come in. This is a great place to add in AI technology. Again, it may not be as latency sensitive in this application, but allows you to deploy AI capabilities out close to your applications, and especially if you're in providing applications where you're bringing in video streams from multiple different types of cameras, say around a city environment, like what MINDsLab is doing. In this type of deployment in number two, you could leave your existing cameras in place and do all of your AI inferencing at the network edge as well, without having to replace your cameras. Categories number 3 and 4 are more traditional server-based applications where you would plug in our Explorer products and Accelerator into a standard rack mount server. Could even be an industrial PC in this case as well. But these are more traditional applications, and it starts really becoming more of an enterprise application, as this equipment may be in some sort of enterprise wiring closet or small network operations center. So let's talk a little bit about our collaboration with MINDsLab. I've had a great opportunity to meet the MINDsLab team face-to-face several times, and we've been working together for well over a year. And we're super excited to see their applications actually up and running today on the Blaize hardware. So moving forward, we see a really long and fruitful relationship between Blaize and MINDsLab as we look at, or as they look at integrating their software and services onto our current hardware and our next generation hardware products coming up. So again, really excited about our opportunity to work really closely with MINDsLab in the region. So let's talk a little bit about an application, and this is very similar to some of the applications that the MINDsLab team is focused on. This particular application, and I'll show a demo video on this as well, is a smart city application where we have several cameras around an intersection, monitoring people, tracking cars, recognizing license plates and license plate numbers for toll tracking and so forth. So in this particular application, we could have anywhere from 5 to 10 HD power over Ethernet cameras connected. We're running 3 independent neural networks at about 50 frames per second each. And then we're monitoring human detection, human pose and position, automotive detection, license plates, overall intersection safety, and so forth. So now let me actually show a live demo. This is very similar to the application, but this is a multi-camera object detection demo. So we'll go ahead and run this, and I'll pick up when it's over.
This is a 5-camera object detection demo running on the Blaize Explorer X1600E small form factor accelerator platform. Here you see 5 cameras in a smart city type of application running 5 different YOLO v3 object detection neural networks in order to detect objects such as people, cars, motorcycles, buses, and traffic lights. These 5 models are required to be processed on the 5 camera streams independently, something that is impossible to do in traditional batch-based architectures like GPUs and VPUs. Each stream is processed independently on the Blaize GSP at 50 frames per second, within less than 20 milliseconds latency each, allowing the complete 5-camera object detection application to run in less than 100 milliseconds latency to achieve true real-time processing on the edge. This multi-stream application runs as independent streaming data flow graphs on the Blaize.
Well, it looks like we had a little bit of a hiccup there. I'm sorry, guys. Let me go ahead and restart the video for you.
This is a 5-camera object detection demo running on the Blaize Explorer X1600E small form factor accelerator platform. Here you see 5 cameras in a smart city type of application running 5 different YOLO v3 object detection neural networks in order to detect objects such as people, cars, motorcycles, buses, and traffic lights. These 5 models are required to be processed on the 5 camera streams independently, something that is impossible to do in traditional batch-based architectures like GPUs and VPUs. Each stream is processed independently on the Blaize GSP at 50 frames per second, within less than 20 milliseconds latency each, allowing the complete 5-camera object detection application to run in less than 100 milliseconds latency to achieve true real-time processing on the edge. This multi-stream application runs as independent streaming data flow graphs on the Blaize GSP to achieve 30 times higher system efficiency compared to edge GPU or VPU solutions.
Yeah, so that was a great application. So we're at the end to wrap things up. So again, I really appreciate the time that MINDsLab has provided, and I hope you guys found the information I shared on Blaize helpful. To wrap up, we do 3 things really well. Number 1 is we've developed a graph stream processing architecture. This is our SoC that goes into a number of different hardware products for embedded and accelerator applications. And at the heart of this, it brings it all together. We have our AI software suite comprised of our Picasso SDK for traditional coding environment and our AI Studio for those who want to use more of a visual code-free environment. So I really, again, appreciate the time from the MINDsLab team. And if there's any questions or follow-up, reach out to your MINDsLab representatives. They know how to reach me. Would be more than happy to have an opportunity to talk with you, answer any questions, provide more information. So with that said, everyone have a great day. Thank you very much. That's the end. And